Hi friends, today's topic is chemical bonding. This is the fundamental chapter in chemistry. By understanding this chapter, you can gain basic knowledge about chemistry and remaining chapters will be very easy to you. Okay, coming to the topic. Our topic is chemical bonding. Chemical bonding. Generally, our scientists discover new compounds regularly. To explain those compounds, they develop some concepts and theories. This chapter also have some theories for better understanding. First of all, we have to know about matter. Matter is made up of one or more different elements. Under normal conditions, there is no element exist as independent atom in nature, except noble gases. There is no atom exist as individual atom. I write one statement, that is, a group of atoms prefers to exist together as one species. Generally, we call these species as molecules. In this molecule, atoms are bound by some force. That force is called attractive force. Okay. Next, you can write down a definition for the chemical bond, that is the attractive force which holds any two atoms or ions. The attractive force which holds any two atoms or ions together is called chemical bond. Any two atoms or ions together is called chemical bond. Chemical bond is nothing but attractive force. At this time, I have some doubts. When we clear those doubts, we can understand this chapter better than earlier. Okay, I write down those doubts one by one. If you have a chance, you can write down. I have 4 doubts here. First one is, why do atoms combine? Second one is, why are only certain combinations are possible? Why are only certain combinations are possible? Third one, why do some atoms combine while others do not? Why do some atoms combine while others do not? Fourth one is, why do molecules possess definite shape? Fifth To clear these doubts, we can understand some theories and concepts which developed by our earlier scientists. Now we have 4 theories in this chapter. Those are Causal-Lewis approach and VSEPR approach and VBT and MOT. We have 4 theories. First one is Causal-Lewis approach. Second one is valence shell electron pair repulsion theory. Valence shell electron pair repulsion theory. We can say VSEPR theory also. Third one is valence bond theory. Fourth one is, in short form, this is VBT. Fourth one is molecular orbital theory, MOT. I will give you a brief introduction about Causal and Lewis approach. In 1916, Causal and Lewis succeeded independently in giving a satisfactory explanation about formation of chemical bond in terms of electrons. They were the first to provide some logical explanation of valence, which was based on the inertness of noble gases. And Lewis given a statement, that is, I write down a statement, that is, Lewis postulated that atoms achieve the octet when they are linked by chemical bonds. Now I take one example, that is sodium atom. Now example is sodium atom and chlorine atom. Here transfer of one electron from sodium to chloride, we got Na plus and Cl minus ions with octet configuration. In sodium atom we have 8 electrons, and also in chlorine atom also in 8 electrons only. In outermost shell there is octet configuration. Here in sodium there is one extra electron in 3s1 orbital. By giving this to the chloride, we get stable ions of positive and negative. Next, I am taking another example, that is formation of chlorine molecule. This is the example for formation of chlorine molecule. By taking 2 chlorine atoms, we get one chlorine molecule. Each chlorine has 7 electrons in outermost valence shell. By sharing these 2 electrons, they got stable outer octet configuration. By sharing these 2 electrons, they got stable outer octet configuration. By the sharing of electrons or transfer of electrons, atoms can form chemical bonds for getting noble gas configuration. This is the example for sharing of electrons. In both, chlorine atoms have stable noble gas configuration, that is 3s2 3p6. This is the stable octet configuration, stable outer octet configuration. Next, types of chemical bonding. Next, types of chemical bonding. Generally, chemical bondings are two types. Types of chemical bonding. Right. Those are two types. First one is interatomic, second one is intermolecular. Interatomic chemical bondings are very strong and stable. But intermolecular chemical bonds are weak bonds. Again, interatomic chemical bonds divided into 4 types. Those are ionic, covalent, coordinate covalent, and metallic. Right. These 4 are interatomic chemical bonds. In intermolecular, we have 2 types: van der Waals forces. Second one is hydrogen bondings. Further, hydrogen bonding divided into 2 types: intermolecular hydrogen bonding and intramolecular hydrogen bonding. Van der Waals forces also divide into 5 types. I will explain about these types in further videos. Next, cause of chemical combination. Generally, chemical combinations are done for the stability. Cause of chemical combination. To achieve octet rule. First one is to achieve octet rule or to attain noble gas configuration, that is NS2NP6 in outermost shell. To attain noble gas configuration, that is NS2NP6. Second one is to lower the potential energy of the system. When energy decreases, automatically stability increases. whenever energy decreases, automatically stability increases. Energy and stability are inversely proportional. If stability increases, automatically energy decreases. Right. For example, if we take A and B atoms, we take A and B atoms. We mentioned as nucleus of A is Na. This is Nb. And electron cloud of A is Ea, and this is Eb. Then we compare some combinations, Na with Nb, Ea with Eb. This is the repulsion to each other. This interaction is repel to each other. Next combination is Na with Eb, nucleus of A with electron cloud of B, and nucleus B with electron cloud of A. This is the attraction force. Above is the repulsion force, below is the attraction force. Attraction force is favorable for the bond formation. If a molecule formed by combining two atoms, then after this distance is called bond length. Right. Then after I will discuss about ionic bond or electrovalent bond. This is non-directional bond. Ionic bond or electrovalent bond. This is not non-directional. Non-directional. First of all, we have a metal and non-metal. Metal easily releases electrons. At the same time, non-metal easily accepts electrons. Here, complete transfer of one electron from metal to non-metal. Complete electron transfer takes place here, metal to non-metal. Taking one example, sodium is a metal. Sodium in gaseous state, by removing one electron, it forms Na+. Na+ has stable noble gas configuration. Next, take one non-metal, that is chlorine atom. It is also in gaseous state. By accepting one electron from metal, it forms Cl-. These two attain stable noble gas configuration, Na+ and Cl- also. This forms very stable attractive bond, attractive force, that is ionic bond. This is very strong force called electrostatic force of attraction. Electrostatic force of attraction. After formation of ions, they combine with each other. Na plus and Cl minus are stabilized with noble gas configuration, but these ions have some positive and negative charges. To neutralize those charges, they combine with each other, formed solid stable compound. Here we have a equation, that is force is equal to K into Q1 into Q2 by R square. Q1, Q2 are charges of ions. R is the radius. Next, this is about the ionic bond. Next, Lewis dot structure. Lewis dot structure. Here we can identify transfer of electron with better representation in Lewis dot structure. Here, so we taken sodium and chlorine atoms. Sodium involved in reaction and transferred one electron to the chlorine atom and form stable octet ions. Chlorine, one electron accepts from sodium metal. In this process, we get two ions stabilized by noble gas configuration. These two ions forms one ionic bond. These ions forms strong ionic bonds. Next, we can take magnesium chloride. Here, magnesium involved in reaction and transfer two electrons to the nonmetals. Magnesium plus 2 electrons. Magnesium plus 2 attains noble gas configuration. Next, here we take two chlorine atoms. These atoms accepts one electron from metal. Chlorines also reached noble gas configuration. To neutralize these charges, they will combine and forms ionic bonds or electrovalent bonds. Between magnesium and chlorine, a strong electrovalent bond is formed. Next, electrovalency. Electrovalency. Number of electrons lost or gained during formation of electrovalent bond is called electrovalency. Electrovalency. Number of electrons lost or gained during formation of electrovalent bond. electrovalency. Number of electrons lost or gained. It is very important point. Number of electrons lost or gained during formation of electrovalent bond is called electrovalency. In periodic table, group 1 metals like lithium, sodium, potassium, rubidium, cesium, general electrovalency is 1. In group 2, beryllium, magnesium, calcium, etc., electrovalency is 2. For group 1, 1, group 2 elements 2. Electrovalency is 2. For group 13 elements, boron, aluminum, gallium, indium, thallium, electrovalency is 3. For group 14, carbon, silicon, germanium, tin, lead, electrovalency is 4. For group 15 elements, nitrogen, phosphorus, arsenic is 3. For group 16 elements, oxygen, sulfur, selenium, tellurium, polonium is 2. For group 17 elements, electrovalency is 1. Group 3 to group 12th, there is D block elements. Group 3 to, for the electrovalency of 18th group, that is noble gas elements, that is 0. Group 3 to group 12, there is D block elements. These D block elements have variable electronic valencies. For example, we take iron, variable electronic valencies. For example, we take iron, it has +2 and +3, etc. Like these, it has variable electronic valency. Next, energy terms involved are favorable conditions. Energy terms involved are favorable condition for the ionic bond, formation of ionic bond. Energy terms involved are favorable condition for the formation of ionic bond. We have 3 conditions. First one is about metal. Metal easily lost 1 electron. For this process, energy is absorbed. This energy is called ionization energy. When a gaseous metal releases 1 electron, it absorbs some energy. That energy is called ionization energy. This should be minimum. For the better ionic bond, ionization energy of metal should be minimum. Second one is non-metal. Non-metal takes one electron from metal. Non-metal takes electrons from metals and forms negative ions. At this time, energy released, that is electron affinity. That energy is called electron affinity. It should be maximum for forming more ionic bond. Third condition is metal with non-metal, metal with non-metal combine in gaseous state, combine to give a ionic compound plus energy is released, plus some energy released. That energy is called lattice energy. Condition is, if more lattice energy released, the ionic compound is more ionic. Condition 3 is, lattice energy should be more. Next, some questions. Here, which is more ionic? Which is more ionic? We have a metal plus non-metal. For the metals, metallic character requires, for the metals, metallic character requires more. For non-metals, non-metallic character will be more to form better ionic compounds. Increase of metallic character and increase of non-metallic character for metal and non-metal respectively. It is the favorable condition for forming ionic bonds. We have some compounds. Compare these for the more ionic compounds. Sodium fluoride, NaCl, NaBr, NaI. We have in all compounds sodium is there. Fluorine has more non-metallic character. That's why it has more ionic nature. Next, lithium chloride, sodium chloride, potassium chloride and rubidium chloride. Chlorine is same in all compounds. Order is according to more metallic character. Left to right, metallic character increases. Then these forms, rubidium chloride forms more ionic compound. General statement is, for groups top to bottom, lithium, sodium, potassium, rubidium, for top to bottom, metallic character increases. Metallic character increases. For non-metals, fluorine, chlorine, bromine, iodine, the non-metallic character decreases. Non-metallic character decreases.